As of now, we have discussed about the Boolean function, Boolean law, and different kind of law we have studied. And we try to solve, like the objective of those Boolean function in the Boolean law was to reduce the function, or suppose I have a function to so to minimize the number of min terms, or to minimize the number of max term, or to minimize the number of variable in any of the min term or max term. This was the importance of the Boolean uh, uh, algebra, which we have discussed before. Now there is one more alternative solution, direct solution, to simplify any Boolean function without any like remembering any of the function, any of the theorem or any of the law. Okay, so the K-map gives you a shortcut way to calculate or to minimize any function. So let us see how this K-map is helpful to minimize the things. Okay, so K-map is basically the is set of squares that is utilized. And suppose if I have n number of variables, okay, in any of the function, suppose I have a function, something, let us assume f is equal to ab plus ab bar c. Okay, if I see this function, in this function, can anyone tell me how many variables we have?
3.
3. Yeah, absolutely correct. Here we have a variable a, b, and c. And similarly, if I have a function something like this, so I have only 2 variables. So based on the number of variable, we decides how many set of square I need to utilize to frame the K map. Okay, so basically the number of square in the K map depends on the variable, and that is calculated with the help of 2 to the power n. So if there are n variables, so 2 to the power n square will be there. Okay, so I just wrote you, like if I have the function f is equal to ab plus ab bar. Okay, so in that case, because we have 2 variables, so we need a set of 4 squares. Okay, uh, basically the K map is represented in 2 ways. The one is for the max term and to represent the max term, and the second one is to represent the min term. So let us discuss one by one. Okay, so let me write few things here and there. Two variable K map for min term and max term. Okay, so let us discuss for both. Okay, suppose if I am talking about the min term representations. Min term representation means if the function is written in the form of SOP, okay, sum of the product form. Okay, then we are calling those terms as a min term. Okay, and if it is in the POS form, then we will call it the max term. Okay, this is what you know. Okay, so I don't need to explain it again. Okay, so now let us try to consider a few things which are really very important. If I am considering, yeah, let me write min term and max term both terms so that you will be easier. So let us talk about the yeah, let me write SOP, SOP term here and the POS term here. Okay, parallelly we will do for both. If I'm talking about the SOP kind of structure, means if I'm talking about the min term, in that case, how we can let us come up with some of the important points that is needed. Okay, in SOP form, if logic 0 is there, okay, in logic 0, if logic 0 is there, so it indicates A complement or B complement or C complement, whatever the variables we have. So let us consider I have a 2 variables only. So to represent logic 0 in the SOP form, or the minterm representation, like for the K map. So for logic 0, I need to use A bar and B bar. And similarly, for 1, I need to use A or B. Okay, so the A and B are used for 1, and uh, A bar and B bar are used for 0. But if I'm talking about the POS, in that case, to represent 0, I have to use A or B, and similarly for 1, I have to use A bar or B bar. So this is the first difference between the SOP K map or the POS K map. Okay. Now let us try to draw the K maps and try to understand how to show them. Yes, one very important thing is K map follows the gray code structure. Okay, what is the gray code structure? Can anyone tell me what is the key point of gray code? Anyone? What is the key point of gray code?
So 0132.
0132. Yes. So and in simple word we can say only one bit change. If I am moving ahead, like the gray code for 0 is 00, gray code for 1 is 01, for 2 is 11, and 3 is 10. So only one bit is changing if I'm moving ahead with this one. So this is the property of the gray code. Okay, so this property will be utilized in the K map as well. Okay, that will be reflected if I will talk about the 3 variable K map or 4 variable K map. Okay, so let me first discuss how the K map is drawn and what is the meaning of all those things, and we will check it out. Okay. So suppose if I have a 2 variable, in that case the total number of squares will be 4. Okay, and let us assume I have this kind of structure. Okay, here I have a, let us assume this side is indicating A and this side it is indicating 0 B. Okay, so and for A and B I can have a 0 and 1 and 0 and 1 both the side. I am considering A is the MSB and B is the LSB. Okay, in that case, if I will combine these two things, what I will get, let us try to see here. If 0 and 0, if I try to combine this with this one, so I will get equivalent to 0. So this is nothing but, this is what we can say, this is 0. If I combine this one and this one, means this row and this column, then I will get to know this one is the thing and this is nothing but this is getting 1. Similarly, this is 2 and this is 3. So this is how we represent the K map values. Now let us try to see how we can do that. 0 simply indicates this is the M0. This is nothing but this is the first minterm. This indicates the M1, which is the second minterm. This is the M2 and this is M3. So this is how we represent the minterms in the K map. Okay, and if you see clearly, this term indicates, like this indicates the, yeah, let me change the color. Okay, so this indicates the A bar, this indicates A, this indicates B bar, and this indicates B. So these are the some of the representations. Now, if I have a function, whatever I have written over here, f is equal to AB plus AB bar. Okay, AB plus AB bar. So if you see AB, so AB, A and B, this particular cell will be the AB. Okay, A from here and B from here, and wherever it will intersect, that will be the minimum we need to place. So this particular cell indicates AB. Okay, this particular cell indicates A, B bar. This cell indicates A bar, B bar, and this cell indicates A bar, B. Okay, so this is how we can indicate here. Now, if we see, if I have a function f is equal to AB plus AB bar, so which of the cells will be they will be like, yeah, so let us try to see these things. Let me draw it again. Okay, so here I have a B, 0, 1, 0, and 1. Okay, so let us assume it is like this. Okay, so can anyone tell me which of the cells will be 1 based on this function, whatever I have? Okay,
First,
third and second one, right? Second. Okay, so second and third will be the, yeah, this one and this one will be the 1, and rest will be the 0, 0. Okay, so this is how we represent the K map based on the function. Okay, so this is important. So if you see here, this function indicates A B bar plus AB. Okay, so this is how we represent the sum of the product form in the K map. Is there any doubt on the SOP form? Then I will talk about the POS, then we can discuss later on. Okay, so this is how we represent these things. I will tell you later on how we can minimize these things. I'm not telling you how to minimize this one, but later I will tell you. Now, if I talk about the POS form, the POS form will be opposite to this one. So let us try to draw the K map, and the K map will look like this one. Okay, yeah, let's make it bigger somewhat. So here I have a K map, which let us assume it is A and B, and the variables are, let us assume these are 0, 1, 0, and 1. This indicates A, this indicates B, A bar, B, and B bar. Okay, and the terms, this indicates the M0, M1, M2, and M3. Okay, and yeah, location is simply just like the same as before, 0, 1, 2, and 3. Okay, now let us talk about what are different terms it represents. The first term, which is here, the first cell, this indicates A plus B. This indicates A plus B bar. This indicates A bar plus B, and the last one indicates A bar plus B bar. Okay, so based on the function, whatever you have with you, you can write 1 or 0. Yes, it is really important. Let me try to write one function. Suppose I have a function something like this. F is equal to A plus B into A plus B bar. Okay, so let us, I have a function something like this. Okay, in that case, how the K map can be filled? So let us try to fill it. Okay, so to fill this one, can anyone tell me which of the blocks will be filled here?
M0, M1.
M0 and M1. Yes, perfect. So M0 and M1. Remember, M0 and M1 will be filled with
0.
0, not with the 1. So these two will be 0, 0, and these two will become 1, 1. And this function indicates A plus B into A plus B bar. Okay. So this is how we can make the K map. So is there any doubt on any of these two representation of the K map? Then we will go ahead with the bigger example. Okay, and I will tell you how to consider it for the three variable as well. Okay, I hope there is no doubt on this. Okay, so let us try to consider some of the yeah. So before moving ahead, let me represent one three variable K map and how it looks like and how to number those things. So this is also important. Suppose I have a three variable K map and I want to make a three variable K map where I have a three variable A, B, and C, and I'm considering A is the MSB, okay, and C is the LSB. In that case, I can have a possibility 0, 1. Now, the important thing is, I just told you uh, for the K map representation, I must follow the gray code kind of structure. So, if I have a two variable in this side, so the possibility could be 0, 0, 0, 1. And if we follow the sequence, it should be 1, 0, and 1, 1. But now, if you see here, uh, initially I have a 0, 0. Now I am moving to the 0, 1, where I am changing a single bit, which is the second one. Now, if I'm changing from here to here, two bits are interchanging. So this is not possible. This numbering is not valid in the K map. Okay, so I have to use those numbers having only one change. So 1, 1 will be there, and the next change will be the 1, 0. Okay, so that is why I'm saying it follow the gray code kind of a pattern. So yeah, this is also possible. Zayan, I will tell you how to do that. Wait, please wait. And I will tell you the numbering as well. Okay. So this is how we can do that. Okay. So if I try to write the numbers, so what are those numbers? Let us try to see. Suppose 0, 0, A, if I'm considering A, B, and C, and A is a MSB. So the total possibility could be like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 100, 101, 110, and 111. So these are the possibilities, and this is the 0, 1, 2, 3, 4, 5, 6, and 7. So these all are the equivalent decimal equivalent for all the binaries. And I just told you, because I have to consider a single bit change, so that is why I need to follow 0, 0, 0, 1, and 1, 1, and then 1, 0. So this is the flow. Now, if I talk about where I need to place the minterms and the minterms here, so let us try to see. This indicates minterm 0, and this indicates minterm 7. We know that. Okay, so let us try to place the values of minterms. If you see here, 0, 0, 0 is here. A 0, B 0, C is 0. So it will be min 0. 0, 0, 1. So it will be 1. If you see here, A is 0 and BC is 1, 1. A is 0 and BC is 1, 1 means what is this? We are considering this one. So this will become the minterm 3, not the minterm 2. So this is the trick here. Okay. So 0, 1, 2. So, and if you see this cell, A is 0, B and C, BC is 1, 0. So that will become equal to this one. So this will become 2. So 0, 1, 3, 2, and then 4, 5, 6, and 7. So this will be the pattern on which I have to put the minterms. Okay. So the minterms will be like, suppose there is some function, minterm is like 1, 2, 5, 7. Okay. So to represent this function, if I will not follow this kind of pattern, so that will create a problem. So in that case, 1, this will be high, this will be high, 2 will be high, 5 will be high, and 7 will be high. Okay, rest other will be 0. Okay, so this is what the importance of. Now the one question Jayant asked, why we cannot keep a on this, what in this direction, a and b on this direction. Okay, so let us try to do that and try to check how we can make the numbering. Okay, so if I will keep ab in this direction, so the structure of k map will be like this. Okay, ab will be there, so 4 cell will be in the vertical direction and 2 cells will be in the horizontal direction. So A, B, and C here. So what are the possibilities here? For C, definitely we have a 0, 1, 2 possibility. For AB, I will have a possibility like 0, 0, 0, 1, 1, 1, and 1, 0. Okay, so this is what we have done. Now, let us try to see where I need to keep the numbers. If you see this first cell, the first cell is 0, 0, 0. So I will write it as a 0th cell. So this is the 0. Now, where will be 1? Can anyone tell me where I need to keep 1? On the right side of this 0 or on the bottom? Or below this 0? Where will be the
Right.
number? Huh?
The right side.
Right side. Okay, because 0, 0, and 1 is coming from here, so this will be 1. Where I need to keep 2?
Sir, below the first column.
Below the
First row.
first column. Okay, so first row, first column, yeah, second one. So here it will be 2. 3 will be here. Okay, where I need to keep 4?
Sir, in the last row, first column.
Last row, first one. Okay, so 4 will be here, 5 will be here, 6 will be here, and 7 will be here. So this is how we can write the numbering if I am considering AB in the vertical direction and only C in the horizontal direction. So this is doable. You can do anything. Considering, very important thing is, I am considering A is the MSB. Okay, if I'm considering A is MSB. Now, can I do one more thing? Let me here in all the cases I'm considering A is MSB. Okay, but I'm changing the position of A and B, and you have to tell me what will be the position. Let us assume here I have a BC and here I have a A, and I'm all again I'm considering A is MSB. Okay, so the numbers will be 0 and 1. Here it will be 0, 0, 0, 1, 1, 0, sorry, 1, 1, and 1, 0. Okay, can anyone tell me what will be the sequence of numbers in this case? I am considering A is MSB. What will be the sequence? Where will be 0?
First row, first column.
First one, here I will have 0. Where will be 1?
Below it.
Below this one. Where will be 2?
Sir, in the last row.
Huh?
Sir, in the last
The
row.
last row. Okay, 2. Then we'll have a 3 here, 4, 5, 6, and then 7. Okay, so you can use any of the variable anywhere, but you should remember how to follow which one of the variable is MSB and which one of the is the LSB, and accordingly you can make it. Okay, so this is the importance of the position. Yeah, so it is doable, so it's not a problem. So is there any doubt on this, anyone? If you have any doubt, you can ask the question. Otherwise, we can move ahead with the example. Okay. Someone has asked question. Yeah, fine. So Jayant, your doubt is clear now, right? Okay. So now let us consider some of the example. Okay. Suppose I have a three variable k map, something like this. Okay, and let us assume I'm placing like A, B, and C here. Okay? And let us assume 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0 I have. And I have some numbers which are, uh, let us given here 1, 1, 1, 1, 1, yeah, something like this. Okay, so if you see here, what does it mean? It means that I'm considering 0, 1, 2, 3, 4, 5, 6, and 7. If you see this one, this function is nothing but, this looks like a summation of min terms which are 0, 1, 2, 3, sorry, not 2, 0, 1, 3, 4, 5, and 6. So this is what the function is. What we have done, we have sorry, we have simply uh, simply converted it into the min term form. Okay, wherever logic 1 is there, I have converted it. And if you try to write this function will be written like, if I want to write 0, so it will be a bar, b bar, c bar, plus if I want to write 1, it will be a bar, b bar, c. For 3, it will be like a bar, bc. For 4, it will be like a, b bar, c bar. For 5, it will be like a, b bar, c, plus for 6, it will be a, b, c bar. So if I have a function, so that function can be represented something like this, but this is not the minimized one. Okay, so we can use two things. Either I can use the the Boolean functions or Boolean algebra to simplify this function, or I need to use the k map. So let us try to use the k map, how we can utilize it, and what are the different regulations associated with the k map. Here I'm considering the SOP form, right? Similar kind of concept will be applied for the POS form as well. But yes, in POS, we will make the group of zeros, but in SOP, we will make the group of ones. Okay. First rule. First rule is we need to try to convert to make the pair of maximum number of ones in the order of either pair of 2, pair of 4, pair of 8, pair of 16, or so on. Like 2 to the power nth order of pair I need to make. Okay. Either I can make the pair of 2, or I can make the pair of 4, or I can make the pair of 8 or 16, or so on. Okay. But this is the first rule that you should consider. Second rule is always try to consider to cover the maximum number of one that can be paired. Okay, it's not like, if you see here, I can make a pair of these two. Yeah, as like I just told you, I can make the pair of 2. I can also make the pair of 4. But if you see here, there are 4 ones which are adjacent to each other, and I can make the quad of these ones. Okay, so if the bigger pair is possible, then consider the bigger one, not the smaller one. Okay, so this is recommended, like I have to make the pair of 4 ones, not ones. I can also do like I can make the pair of 1 and 1. This is true, but this will not give you the minimum or the minimized function. Okay, some more variable will be there. So to get the minimum function or the minimized function, we need to try to consider the maximum number of ones that we can make the pair in this order, whatever order I have. So this is the first thing. Okay, second thing, We can also make pair on this side and on this side. So this side, like this, we can call it the rolling kind of. We can roll it and we can make the pair. Okay. So if one is here and one is here, so we can make the pair in these two cells. It's not like I have to make pair only with this one. Okay. We can make the pair here as well. Okay. Why we can make the pair here as well? Let us try to see here. See, we can clearly see we can make the pair here because these two are adjacent to each other. Okay. And to consider whether these two numbers are adjacent to each other or not, we need to check if there is only one bit change in these two numbers, then we can call it they are adjacent to each other. Okay. So if you see here, this one indicates 0, 1 and this is 1, 1 and only one bit is changing, so these two are adjacent, and we can clearly see from the K map as well, like these two are the adjacent. But by the first look we cannot see like this one and this one are adjacent to each other or not. So let us try to see whether these two numbers are adjacent to each other or not. So let us see. If you see this one, here I have a 0, 0, here I have a 0, 1, and if we try to compare these two one, only one bit is changing. Okay, only one bit is changing. What it means? These two are adjacent to each other. So this is just like a cylinder, and if I have a paper and the end of one paper is connected to the another end, and I make a cylinder kind of a structure. So this is how the K map looks like. So this cell is adjacent to this cell as well. This cell is adjacent to this cell as well. Okay, so we need to consider how we can make the cells adjacent. Okay, any doubt on this? Okay, if you have any doubt, you can ask the question. Okay, so this is the first thing. Third thing. Okay, so let us try to solve this question, and we will be able to understand the things. Okay, suppose I have to start pairing. I just told you before, I need to start pairing with maximum number of ones in this order. Okay, so let us try to see, because the maximum number of cells are maximum number of squares are 8. Okay, so the maximum possibility of pair could be 8, but because all the 8 squares are not filled with 1, so this is not possible. Now the next possible is I need to check whether there is a quad is possible or not. Like quad means like the pair of 4, or like 4 1 can be grouped. Okay, the quad is possible or not? Yes, I can see the quad is possible. Can anyone tell me which of the quad is possible? Where is the quad which is possible? Okay, if you see, this quad is possible. Okay, so 0 1 4 5 is possible. Perfect. Okay, so this is called. Now I have considered the 4 ones. Okay, now 2 ones are left. Okay, so I need to find the way how we can make pair of those 2 ones as well. So if you see here, this one can be paired with this one, so that min term can be considered. Okay, so we can make pair with this one. So what it means, there is a the next rule comes here. If I have made a pair of, or make I have already made a quad or the pair, so any one of the ones can be considered, or any one of the min term can be considered to make the pair with others as well if needed. Okay, we'll try, like first try to make the pair with unused one, but we are not, if we are not able to get any of the unused min term to make the pair, so we can use the used one as well. Okay, so this is what we have used here to make the pair. Now if you see here, this looks like alone. There is none, there is no one is here, there is no one here, there is no one here. Okay, so I cannot make pair in this direction or in this direction, but I just told you this is the folded one and this cell is adjacent to this cell, so we can make the pair of this 6th cell with the pair of 4th cell. So 4th cell and the 6th cell are adjacent to each other, and definitely we can make pair of it. Okay, so let us try to make the pair of this one. So this one can be paired. Okay, so this is how it is we can make the pair. Now after making the pair, let us try to solve the answer, solve this result. Okay, so what will be the result? Let us try to see. Let us first consider the bigger one, which is in the blue color. If you see here, A and A bar both are considered here. Okay, so the cells, like if I have made a group, so A bar and A both are covered. Okay, so if both are covered, that variable will be cancelled out. Okay, so if both are covered, then that variable will be cancelled out. If you see here, okay, here I have a B, here I have a B, here I have a C, and here I have a C bar. So C and C bar is covered, so C will be cancelled out. If both the possibility of any variable is covered, then that will be cancelled. Okay, so if you see here that because C and C bar is already covered, so variable C will be cancelled out, and only 0 is left for B. Only this is left, so 0 indicates B complement, so directly I can write B complement. Let me repeat it again what I did. Let us first consider this blue pairing. Okay, blue circle, and this one, if you see, A bar and A both is covered. Okay, A bar and A is covered here because this is covering this one. A bar and A is covered, and if you see here, C bar and C is covered, and B bar and B bar is here. So because B is not getting pair of 0 and 1, so B will not be removed, it will not be vanished, only A and C will be vanished. So directly we can write B bar here. Okay, because only 0 was here, 0 for B was present. Okay, this indicates B, and this is nothing but this is the B bar. Okay, so that is how B bar comes. Now let us talk about this purple one. If you see the purple one, A bar and A both are not considered covered, so only A bar is here, so definitely A bar variable will be present in the output. Okay, now if you see here, if you see these two pairs, B bar and B is considered, so B will be removed, and here if you see, C is 1, so A bar C will be the outcome of this pair. Okay, now can anyone tell me what will be the outcome of the third pair, which is in the brown color?
AC bar.
A C bar. Perfect, because A is not making pair with anyone. B will be removed because B bar and B both are present, so AC bar will be the output. Okay, so AC bar will be the output. Now the question is, now you can see here this expression. This expression gives, like, if I am making the bigger pair, I will get less number of variables because I had a quad. So with the help of quad, I removed 2 variable and I got only 1 variable in the final expression. Okay, and if less number of pairs are there, more variable will be included. So that is why I am just saying you should include more number of ones or 0 in the pair, whichever is possible. Now let me try to write the same truth table in different way, and to justify why we need to make a pair of bigger group. Okay, so this was the K map, something like this, A B C. I'm not making it fully detailed. So the number was 1 1 1 1 and 1, something like this. We had a number like this, and if we try to make the pair, we can make the pair something like, let us assume I can make pair this one, I'm making pair this one, I'm making pair this one, and I can make pair this one. So this is also possible. Someone say, okay, I have made a pair of all these things. without considering the bigger pairing or the chord or something like that. If I try to simplify this one, can anyone tell me what will be the function, output function for this one? What is the output function for this one? So the simplified function of this one will be like, yeah, so someone has replied perfectly. So let me try to write that thing. That will be like in the first one, a will be cancelled out, okay, and here I will get b bar c bar, okay. In the second one, if you see here, in the second one, again a will be cancelled out, and I will get uh, b bar c. And the third one, if you see here, in the third one I will get a bar from the left, and the b will be cancelled out, so I will get c. On the fourth, I will get like a will not be cancelled out, a and here the b will be cancelled out, so ac bar I will get, okay. So if you see here, why I am doing like this, if you see these two expressions, okay, both we can claim that these both are the simplified than this expression, whatever we can see here, okay, we can claim it. But the important thing is, if you see the number of the terms, product terms, and the number of sum terms in this function is less than this one, okay. So this one is more simplified than this one. So if you will not make the pair of bigger group, then that will increase the number of sum term or number of the product term, okay. So this is the problem. So we need to try to consider as maximum number of one as possible, following the rules, okay, with following the rules. So this is important, okay. So finally you will get this function based on that k map. Okay, so I'm assuming that you understand the k map concept of k map, how it works and how we can make the pair. Similarly, you can also make the k map for 4 variables, okay. So 4 variable k map can also be drawn, and you should know these things, okay. Yeah, so this yeah, if you try to fill up this one, so this 0 0 1, yeah, this gives you 1, and then for 1 it is 1. Yeah, so this is a table what it is there, it's not that much important, yeah, but it is drawn, that is why I'm making it 1 1. 5 is also 1, and then 6 is 1, and rest 2 are the 0 0. So this is the table. Now let us try to solve one problem. Suppose I have a function which is f is equal to wxyz, which are the variable here, okay. And can anyone tell me this function is in the sum of product form or the product of sum form?
Product of sum. The product of sum.
Yes, perfect, because there is a pi symbol here, right, and capital M is used, okay. So the pi symbol indicates we have the function that is in the product of sum form. If the product of sum form is given, what it means, I have to make whatever the maximums are available here, those maximums will be 1, okay. So let us try to make that one. Yeah, so here directly I made it. Here I have a not A B C D, okay, it will be W X Y Z. I just, okay. So this will be WX and this will be YZ, okay. So we have 4 variable WX YZ, okay, and the numbering will be something like this here. So if I have considered, yeah, I'm considering W is the MSB. In that case, it will be, the sequence will be 0 1 2. Oh, I made one mistake here, okay. It should be 0 1
3
2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So yeah, this will be the sequence, okay. So 0 1 3 2 4 5 7 8. Yeah, so why I just wanted to tell you, we need to follow this row, and then we need to come to the last, and then this one. So if you see here, the MSB is this one, and the lowest weight on the number is this one, and the highest weight on this one. Okay, so this is the cell where we can put the highest weight, which is the 1111, and this is the cell where we can put the minimum weight, okay, which is 00. Now let us try to fill this data, how it will look like. Let us see. Okay, so here I need to fill zeros on 0, 5, 6, 7, 11, 12, 13, 15. So these are ones which we can make. Now I have to make the pairs. Okay, how we can make the pair? The first pair, if we see here, can anyone tell me which is the maximum number of zeros where we can cover which group of zeros?
5, 7, 13, 15.
Perfect. 5, 7, 13, 15. That gives you the maximum number of zeros that we can make the quad. Okay. So here, this is the first one which we can make. Okay. This is the first pair. Now, if you see here, we have left 4 zeros which are unpaired, and adjacent to those zeros, we have some zeros as well. So we can make pair with this one. I can make pair with this one. I can make pair with this one, and I can make pair with this one. So this is how we can make the pair. Now, if we try to write the output function of this one, can anyone tell me what will be the output function of this one? That will be simply like, if you see the central one, on the central one we can have if you see, this portion is covered and this portion is covered, and in this portion the first section is complementary, so W will be removed. Here I will get X, so X will come out, and if you see here, from this side, on this side Y will be cancelled and Z will be come out, so X. So what will be the output? Can anyone tell me?
X
Sir,
bar
X
plus
bar
Y
plus Z.
plus Y.
Yes,
Z
this is
bar.
what I wanted. It will not be X, it will be X bar plus Z bar, because here we have considered 0 and 1. So one will be represented as a complement, and other will be represented as the normal one. If you see the second one, yeah, this question is very important actually, right? So I will tell you one more regulation after this one. Okay, so if you see this pair, in this pair, that will give you like these two are considered, so W, which is 0, so I will get W here, and from here, if you see there is no pair, so I will get Y plus Z bar. From this one, if you see that I will get W plus X bar plus here the term Z will be cancelled, Y will be there, so 1 is there, so Y complement will be there. If you see this pair, in this pair I have W bar plus X bar plus, if you see on the top, I have Z will be cancelled out, Y is there, so that will be Y, and the last one will give you like from this side W will be considered, so W bar plus on the top it will be Y bar plus Z bar. So this is the final expression which we are expecting. Now, if you see here, I have 5 max terms. Okay, so 5 max terms I can see here. One is this one, second one is this one, third, fourth, and fifth one. Okay, 5 max terms are here. But if you clearly see here, even though I have made a pair of 4, if I remove this one, if I do not consider this one, also even on that case, all the zeros are considered. Okay, so here one rule is very important. I just told you before, I have to make a pair of maximum number of ones uh, or the maximum number of zeros. Okay, that is what we have done, and accordingly we have solved this one. But after looking into it, we can see that the other pairs are like all the zeros which we have made a maximum pair, that all the zeros are covered with the other pair as well. So if we do not consider this one, so even though that function will be same as whatever we want, right? So it is not mandatory that we have to always consider the maximum pair. Even though you have considered it, but this is covered with the other lower pairs, and if it is done, then we can remove this one. It is not mandatory to use this one, we can remove this one. So the final function could be with the help of only these four max terms, and that will give you the less number of logic functions at the output. Okay, so this is a trick in this question.